Okay, so for section 3.1, level 1 is factoring with the greatest common factor. So we've got a couple different examples, two different types, is just saying what the greatest common factor is, and then factoring a greatest common factor out of an expression, and then writing the leftovers with variables. So if you look at A, we've got the numbers 48 and 72. So if I list the factors of 48, it would be 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. So remember, a factor is a number that goes in evenly, so it divides. So all these numbers get divided evenly into 48. Same thing with 72. You got 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and then finally 72. So your greatest common factors here are, let's see, you've got, I think 24. 24 is the largest number that they have in common. So you'd say the GCF is 24. Now going over to this, letter B, now I've got variables in it. So just like with the numbers before, we want to know the greatest common factor first. So this one, first, so for 7x to the fourth, we could write it as the greatest common factors are just 1 and 7, and they have 4 x's. For 49, x to the fifth, it would be 1, 7, and 49, and I have 5 x's. And for 28, x squared, it would be 1, 2, 4, 7, 14, and 28, and then x times x. So looking at the numbers, the largest number that they all have in common is 7, and then the largest amount of x's that they have is 2. So the greatest common factor for B would be 7x squared. So now we look at C. We got 42 x to the third y. So 1, 2, 3, and you can keep on going, but I'm going to stop here and I'll give you a reason right now. You've got 42, 3, and 6. Well, thinking about the factors of 3, it's just 1 and 3. So you know that 3 has got to be the greatest factor in the second term. And you ask yourself, does 3 go into 6x to the third y? And it does. And does 3 go into 42? And it does. So I don't have to list all the factors. I just usually look at the smallest number and look at those factors and then test them out. So I already know that my greatest common factor is 3. I'm going to go ahead and get rid of this. So it's going to be 3. I'm going to write out all the x's that I have and the y's. And then 3x to the fifth, y to the second would be 3, and then 5 x's and 2 y's. And 6x to the third y would be 3. So we know that the 3 they have in common. They have 3 x's that they share, and they all have 1 y that they share. So the greatest common factor is going to be 3x to the third y. So that's stating a greatest common factor given a set of numbers. Now let's look at what it means to factor using a greatest common factor. So we're going to do the same thing here with the 5x. 5x and 20. Okay, again, looking at the smallest number, 5, the only factors are 5 and 1. And then 5 does go into 20. So I know the greatest common factor is going to be 20. But how about for the x's? For 5x, there is one x, but 20 doesn't have anything. So the only thing they have in common is a 5. Now I'm going to write what's left over here in my list. 1 and x are left over from the 5, so I can just write an x. And then keeping the same sign, the subtraction sign, in order to get back to the original problem, the factor of 4 is left over from the 20. So you can always check your work to see if you're doing this correctly by distributing this back out. If you were able to, you'd be 5x minus 20. And since you got back to the beginning of the problem, you know that you're doing it correctly. So the correct factored form in A is 5 times x minus 4. All right, going on to B. So we've got 16, 8, and 4. So 4 is the smallest, and I'm going to check to see if 4 goes into 8, and it does, and 4 does go into 16. So I know my greatest common factor here is going to be 4. And then we've got 7 A's here. Three A's in the second term and 1 A in the last term. So the most they have in common is just 1 A. So the greatest common factor is going to be 4A. Now, anytime the first term is negative, I usually pull out a negative 1, and that keeps the first term positive in your group of leftovers. So now I'm going to think about, okay, well, what gets me back to 16 if I multiply it by 4? And that answer would be 4a to the 6th because there's 6 a's left over. Okay, the second term, what am I going to multiply negative 4a to get to a positive 8a cubed? The answer is going to be negative 2a squared because there's 2 a's left over. Now a lot of you might be thinking, well, the last term doesn't really matter, but it does. Anytime you start with 1, 2, 3 terms, or 4 terms, or 5 terms, your leftovers have to have that many terms as well. So again, you're going to look back and say negative 4a times what equals 4a, and that's going to be a negative 1. So this would be your final answer. And if you multiplied it all back out, you'd get back to the beginning of the problem, which is how you know that you're correct. Okay, now we've got a couple different variables here. Looking again at the smallest number, you got 13. Does 13 go into 52? Yes. Does 13 go into 39? Yes, it does. So I know that my greatest common factor is going to be 13. Now it's just for the variables. So for the first one, we've got m squared, or 2 m's, and an n. For the second one, we have m and an n. And for the third one, we have 3 m's and 3 n's. So that what they have in common, they have at least 1 m in common and at least 1 n in common. So I know my greatest common factor is going to be 13 m n. And then what's left over? So I know I got to fill in 3 blanks. 13 times 3 gets me back to 39. And there's just 1 m that's I haven't used in that group. For the second term, 13 times 1 gets me back to 13. And I circled both m and the n, so the second term is just a 1. For the last one, we've got 13 times what is negative 52, and that answer is going to be negative 4, and I have 2 m's left over and 2 n's left over. So 13mn times 3m plus 1 minus 4m squared n squared would be your final answer. And again, if you multiply this all back out and distribute it, you'd get back to the very beginning, which is how you'd know you'd be correct. So go ahead and try the level 1s now in the practice and then take the quick check.